Hi, I'm Brendan Runham, and I'm reviewing the academic paper by authors Zhong and Buyya regarding a cost-efficient container orchestration strategy in Kubernetes-based cloud computing infrastructures with heterogeneous resources. So the issue here is that container orchestration strategy needs improving. Quality of service doesn't really work for various types of workloads out of the box. And the reality is that we now have elastic compute resources. The nodes differ in multiple dimensions quite often, including actually having physical and VMs. And then we also have various types of workloads. Main two that are being compared in this particular paper are shorter batch type things versus longer running workloads. And task scheduling only target on specific workloads or environments. It's become broken with poor performance over time as everything started changing from having homogeneous resources to heterogeneous resources. Why is this still a problem? Well, container orchestration is really led by CoreOS Fleet, Google Borg, and mainly now Kubernetes. They have mature features, but the optimization strategies, as I said, are still tailored to a homogeneous resource type situation, to the static cluster, and also the focus is on infrastructure level type metrics. So they're not really looking at the application response time, for example, as a real metric out of the box. Related work in this field, so lots of people are trying to come up with the best algorithms to improve load balancing and bin packing and all sorts of things. As you can see there, it's quite a list. And they're running across different platforms as well. So whether they all work on the Kubernetes platform remains to be seen. So worth noting is that Buyya's name turns up there a couple of times, especially I think later on in this paper we refer to the Rodriguez and Buyya paper as a starting point for something else. So there's a HTAS down there in the bottom left-hand corner, and that is the heterogeneous task allocation strategy that the authors are proposing here. So what makes that up? Okay, looking at heterogeneous task allocation. So we want to actually get the initial placement of containers worked out correctly. We want to look at elastic instance pricing model for cluster size adjustment. So that's to deal with workload fluctuations at runtime. And in doing so, they're going to use multiple auto-scaling algorithms. And then there's a rescheduling mechanism there to have a look and see if any of the VMs need to be cleaned and resources released, but done in a way that we don't lose task progress. So basically that means waiting until all workloads have disappeared off a worker node. And as you can see there, again, the main engine is talking to the API server on the Kubernetes cluster. And it can basically control the Kubernetes cluster after it's worked out what it wants to do. How is this better? Well, the results are out. So if this particular paper has a lot of graphs. I've used 3 slides for these. So this is versus a stable growing cycle and on-off patterns of load, of requests. And the first set here show that the HTAS, very top left, the cost is the lowest, but the scheduling time in this one instance is actually higher on a stable load. And then in every other type, the growing, cycle, and on-off, it's winning the cost battle and generally mid-pack by the looks of it on the scheduling time. Now these graphs on the left show across those stable growing cycle and on-off loads that the HTAS, which is generally the lower yellow line, is actually balancing the resources better and has slightly less utilization percent than the others. And the right-hand set of 4 is showing that it is actually using more nodes than the other strategies. So moving on, migration frequency, sort of mid-pack there. The number of nodes used a little bit higher than the others. And then finally, showing that it actually can deliver quite well on node provisioning, progress, task termination, container migration. In order to test this, I used the Australian National Cloud Infrastructure from Nectar. They said they're going to compare their HTAS to the related algorithmic work and to the default Kubernetes, COCA and Stratus algorithms that have come out of the box. And there you can see the batch types and the long-running service that we're alluding to, and the input to all of those systems, showing the stable, growing cycle and on-off patterns. So this was 22 pages that was actually extremely easy to read, excellent layout and style, I thought. Problem and cure were described really well and in depth. So there again is a bunch of mathematics that go and read in there. The testing method was clear. The great support graphs showing that they're getting the results they required. However, but they didn't compare their results to the others' work in this area, just to what came out of the box, which was a bit disappointing. It would have been great if there was a way to actually show how they compared against the others in the field and their algorithms that had been dreamt up. Overall, a recommended read. That's it from me. Ciao, ciao.